So, hello guys, you're welcome to another wonderful video series from MOSDEE Academy. This video series is going to be a kind of exam readiness series in which we are going to be looking into questions in our physics, and those are going to be available on the physics channel, as well as chemistry and mathematics daily. So what we do is taking the topic concept-wise and topic-wise. So we are going to cover all the topic in the syllabus. So we are counting down to the days of the day of the exam. That is for students writing Utme and Waec. So, and because of this series, I'm going to stop my video series of comprehensive concept video series till after this series stopped or ended. So, my dear students, I urge you to actually share, like, and subscribe to our video channels, our MOSDEE academic channels. We have for physics, for chemistry, and for mathematics. Like I said, I'm going to try as much as possible to make sure I cover every details with respect to questions, because I think that is the best way to help students. It was suggested by some of our students that I should please do that for them so that they can actually have the confidence to tackle and face examination questions. And most recently for UTME students, which is popularly known as JAMP, there are new question pattern series. So most of my questions are going to be with respect to the new series, because as you all know, there is no more past questions for UTME. Most of the questions you see around are consolidated questions. So permit my voice for this video. Like I said, I'm going to get better with the voice. Don't forget, if you find this video interesting, don't forget to like and subscribe to the channel and share with your friend, because the aim of this is to make sure you will pass your forthcoming examination. So enough of the advertisement. Let us start with the business of the day, which is the first on physics. And here we are talking about linear motion, or what we call rectilinear motion, or basically what we call motion on a straight line. So we have 10 question series which focuses on that, which I'm going to do, and I'm going to take you through there, and I'm not going to waste your time. So let's start with the solution. So the first question: which of the following is not possible for a body in uniform motion? Which of the following is not possible for a body in uniform motion? Now, when we say uniform motion, which is a key word here, we are talking about body moving at constant speed or constant velocity, or if you like, you say constant acceleration. So you can keep that at the back of your mind. So which of the following is not possible for a body in uniform motion? So far we're having displacement over time. A displacement time graph illustrates what we call velocity. Place, because displacement over time is velocity. So directly we can say for this body is moving at uniform. You can see uniform because it's constant at different position of time. The value of the displacement is the same. And at this point, if you also check, you can see here the time is constant. At another position in time, there is no value for displacement. So what you just need to get here, then, student, is that when you talk about uniform motion, that is a constant rate of change of what? Either displacement with time or velocity with time. So by and large, what we are saying is that both A and B can be represented with this graph, because you can see the time here is constant, the time is not changing. Here, that at different position of time, you can see that what the displacement is what uniform. So my point here for you to understand well, I'm wasting too much of time. I have concept of this. Displacement here is said to be what? To be constant. But here we say the displacement is zero because it's only what at a particular time that what you have what a kind of a straight line there. So what I'm saying in essence is that both A and B cannot be written as a uniform motion because time is changing, and because of that, only displacement is constant here, time is constant here. So both A and B is correct for this question, and you can pick what option C. So please note that. The second question is a particle moves from, you have coordinate 2 to 3 meter, then towards 4,1 meter. The question is the displacement is dash. The magnitude of the displacement is dash. Now, to solve this question, we must know the definition of displacement. We define displacement as the shortest distance between two positions, or the distance traveled in a specified direction. So now we're having this in terms of plane or coordinate. What you just need to do is just following your coordinates geometry. You can just get the displacement between, this is point X and Y. These are coordinates. These are also X and Y. So mathematically, you say the first points are X1 and Y1, while the second point are X2 and Y2. So get the displacement. That is here, the distance traveled here is coordinate X is equals to 4 minus 2, which is equals to 2 meter. I hope students still remember this. And the distance traveled in Y coordinates is 1 minus 3, which is also what? Negative 2 meter. So the displacement of the two is now equals to the square root of the first distance plus what? The second, negative 2 squared. So this is the way you do that. So, and if you go by that, this should give you nothing but square root of 4 plus 4, which you all know, and that is a square root of 8. You can ask me, where is this 4 coming from? Minus 2 square is 8. So if you go by your short form, this is 2 root 2, which is in meter. So this is the way we calculate the displacement of two bodies when they are given in coordinates. So please, it's a new pattern of question which most students need to keep at the back of them. So please, the first one we pick C. The second question we also pick C. Then we move to the next slide. Now about this next slide, we have the question is still on motion in one dimension. And we are given the velocity time graph of the motion of the body is shown. You have velocity against time. The total distance traveled is dash. I think this should not be something that is difficult for us. Total distance traveled for a velocity time graph is always area under the curve. Always keep that, area under the curve. From here, the area, I said the total distance traveled for those that are beginner is always the area under the what? Area under velocity time graph. So area under the curve we have here is a trapezium. So it's always given as area under the curve. So if we go by that, the curve we have here, the area is area of a trapezium. And the area of trapezium is always half the parallel side addition multiplied by the height. So in this case, we go with what? The values. We can say this is 1 by 2, which is half. Open a bracket. The parallel sides you can take as look at this, OC. The other parallel side is AP multiplied by the height. It goes without saying the height. You can see the height here. The height is distance from this to this. The height can be AD, it can also be BE, depending on the examiner. So in this case, we are going with AD, because AD is parallel to BE. So we go with options that look like this. I think the correct answer is OC plus AB half multiplied by this is also C. So I think answers to most of these questions are C. Well, we never can say we are still doing the question. So we move to question 4. Like I tell you, it is just 10 question series which are based on topic. So I'm going to take it topic by topic, day by day, till the day of the examination. So the next question is the displacement of a particle is represented by the following equation. Displacement x is equals to 3t cubed plus 7t squared plus 5t plus 8, where s is in meter and t is in seconds. The acceleration of the particle at t is equals to 15 is dash. Now, this is more like what we call instantaneous acceleration. Now, to solve this type of questions, you are going to use your knowledge of differentiation. Like I said, topic-wise, I have videos on topic. If you have time to study them, you can actually watch those videos. But directly, acceleration is taken as rate of change of what? Velocity with time. Keep that on the back of your mind. Acceleration is rate of change of velocity with time. We are given a displacement time graph. So if we did what? If we differentiate displacement time graph, we are going to get velocity. If we differentiate velocity time graph, we are going to get acceleration. Like I tell you, UTME has actually changed question pattern. And this I am doing is to help us students to actually get their desired score. So here directly, my dear students, we can say we have to differentiate first. If we differentiate first time, we are going to have velocity because the s by the t. From your knowledge of differentiation, 3 times 3 is 9. T, subtract 1 from the power, you have square. When you differentiate this, you just watch when the power is 1, just pick the number beside. This is 7. The same thing here. Okay, there is a square here. You can see I have to follow the line of the question. So it will be 2 times 7. 2 7s are 14. Then subtract 1, you have t. This is plus, like I said, 1 times 5 is 5. So that we go. And when you differentiate a constant, it is equals to 0. Having done that, the s, the t is what? Velocity. So if you have gotten velocity, this is velocity now, which you can write as velocity is equals to 9t squared plus 14t plus 5. So now you are looking for the acceleration after the time of 15 seconds. So now you have to differentiate again because velocity over time is acceleration. Excuse my voice. Excuse me. 2 times 9 are 18. Subtract 1, that is 18t. This is 1. Just pick 14. The t will go. Like I told you, when you differentiate a constant, it is always 0. So what you have gotten here, my dear student, is velocity over time, which is equivalent to what? Acceleration. So the acceleration is equals to 18t plus 14. So directly now, at the time of, you can now say when t is equals to 15. When t is equals to 15, so directly you can get your answer. So you can get this by saying, I don't think this is 15, maybe it is 1 second. I just guess this is not 15, 1 second. So it should be when t is 1 second because of what I'm saying here. So when t is 1 second, this is not 15. T is equals to 1 second. Because with 15, your answer will not be there. So 1 second, please. So you said acceleration will now be equals to 18 into bracket 1 plus 14. So there's an error in the typing there. 18 plus 14 is 32 meters per second square. Like I said, I think answer to this my question that was compiled by my students is C. No options are C. So maybe we don't need to waste our time to do any other thing. We can just continue to pick C. But don't let us do that. Let us continue to solve. So guys, that is how you tackle that kind of question. We move to the 5th question. About the 5th question, the displacement of a particle as a function of time is shown in figure. It indicates dash. Wow. Well, on the understanding of your displacement time graph, which we call velocity, like I said, if you have any doubt with all this I'm doing, you can watch the video concept they are available on the channel. You can just search using the channel link under the channel. You can search. So, my dear students, if we go by this, we can say directly here, it's a very simple one. Very, very simple one. If we take something here at 40, you can see at 40, I want to take something like a ruler. At 40 seconds, the velocity is constant. It is 30. The displacement is 30. At 30, it is also 30. The displacement is 30. But the moment we now watch, as we go down with 30, you can see the displacement is now what? Reducing. You can see. And finally comes what? You can see. Until it's what? It comes back to what? Comes back to rest. So my point is, it is not always you starting your motion like this and you say it is moving. You can also start from the back to understand. So this type of question, a new pattern in which JAM or UTME has taken in recent time, and it is affecting some of our students that are not so good in the concept. So my point, dear students, is that the motion of the body here is decreasing. As you can see, the body is constant, the displacement is what's constant, and later it's coming down. Once it finally comes to what? Rest. So we can say the velocity of the body is constant throughout, is very wrong. The acceleration of the body is constant throughout, is very wrong. The particle starts with a constant velocity, is very wrong. The motion is retarded, and finally a particle stops. You can see this is the motion, and please be careful about it. It started like this and come back to rest. So this is the answer to that question. I think this should be a bonus for those of you that you have watched my video. Now, the next, guys, is the velocity of an object moving rectilinearly, that is on a straight line, is given as a function of time as v is equals to 40 minus 3t squared, where v is in meters per second and t is in seconds. The average velocity between the particle at time t equals to 0 and time t equals to 2 seconds is that. Like I tell you, we are doing linear motion. I don't expect us to have any issues with getting the answer. Average velocity we call velocity average, v average. It is between two time interval. So it is just the total distance, but the addition of getting the velocity of the first one plus the velocity of the second one, then dividing the total velocity by 2. Average of two numbers is addition of the two divided by 2. You can see they are simple, but you need to practice and understand the pattern so that you can know how to get the answer. So by this average velocity, I am not calculating instantaneous velocity. So I am not differentiating. So be careful about questions. Now here, average is just addition of each of the velocity. So when the time is equals to 0, the equation was given as 4t minus 3t squared. At time t equals to 0, my dear students, if you put 0 in here, you are going to get 0. 4 times 0 is 0. 3 times 0 squared is also 0. It's 0 meters per second. At time t equals to 2 seconds. I hope you are following. We substitute t equals to 2 seconds. We are going to have velocity will be equals to, doing that here, 4 times 2 a minus 3 open brackets 2 squared. On simplification, if you give us 4 times 2 is 8, minus, you are going to do the exponential first. 2 squares are 4. 4 times 3 are 12. 8 minus 12 is negative 4 meters per second. So therefore, dear students, you can now say the average velocity will be modulo. We put it in modulo anyway, but it's not possible because you are getting average velocity. Now, here in this case, we say is 0 plus negative 4 divided by 2. Plus times minus is minus. So negative 4 over 2 will give you negative 2 meters per second. So guys, that is the correct answer to that question. And that is for the first time today. Our answer is not C. Our answer now is what? Is B. So that is, in fact, the other answer here, I did not check that, was also what? D. So the next question, I think is question 6 or question 7. So let's say this says that, let's see this. a body A begins to move with initial velocity of 2 meters per second, we can just keep down important information. Velocity is 2 meters per second and continue to move at constant acceleration. So acceleration is constant and the change in time is equals to 10 seconds. Very good. After the body A begins to move, a body B departs from the same point with initial velocity. This is velocity of A. The velocity of B is now 12 meters per second and moving with the same acceleration. That means the acceleration is both constant. What is the maximum acceleration at which body B overtake body A? So far, the acceleration of A is equals to the acceleration of B. We have learned from equation of motion that acceleration is equals to change in velocity over time. So the body will move or the body will overtake each other at the point at which there is a change in velocity. The rate of change of velocity is equals to time. Most of you know this formula as V equals to U plus AT because it's the same thing. So what we are saying is that they are moving with the same acceleration. So, but the point at which the maximum acceleration, that is the highest acceleration, at which the second body will overtake the first body will be equals to, using the equation of motion of A equals to change in velocity over change in time. Their change in velocity, the first velocity of B minus velocity of A over the time. The change in time between the two bodies was 10 seconds. So at this particular acceleration, the body will overtake, but the second body will overtake the first body. And we can say this is 10 over 10. So by matter of calculation, this is 1 meters per second. So guys, that is the right answer to the question. You can see very simple questions, but if you don't have the idea, you are going to miss it. The next is a body is thrown upward and reaches half of its maximum height. Body is thrown upward. Let's take an illustration. Body is thrown upward. Wow. The body is thrown up. So now this is the body that was thrown upward. Then, having said that, the body was thrown upward. You know, when the body is thrown upward, the final velocity here at the maximum height, this is maximum height. That is H maximum, the way we write it. The final velocity at maximum height, velocity at maximum height is always equals to 0. When the body is thrown up, you know, it will be retarded by G. Gravity will hold on the body. These are basic things we've talked about for those that have watched the concept. And if not, you can still get there because it is question-wise and it's going to be in terms of chapter-wise with respect to your syllabus. And the most important thing is with respect to the new pattern. Time is not on my side. Now, look at the condition. The body was thrown up and reaches only half. You can see the technicality is that the body did not reach the maximum velocity. I did not reach the maximum height. So the maximum velocity is not 0. So it's a non-zero maximum velocity. I hope that is getting this. So guys, at this particular point, the only force that is responding, you know, the body is moving upward with an acceleration, which we don't know. You can say the acceleration of the body at this point is A. So the only body that is what? The only force that is acting on this body at half of the initial velocity here is, we can say it's what? It's the gravity. So we can say if the body is thrown up and the body has only reached half of this, what? You can use the equation of motion as well. In fact, you can use the simple equation of the motion of your H is equals to half what? GT squared, which you guys know very well. Now here, you know, the H is now half of the initial, but you don't need this. You just need to understand the interpretation. At this particular position of half of the height, that is H by 2, that is the value of H by 2. The value of the gravity that is acting on this body is constant because the body is still going up. So we say the height is proportional to the what? To the gravity. So the only thing here is that what? The body is moving at constant acceleration. You can see this from this relationship. You can try it out. You can see that it said h is equals to half gt squared. H by 2. You understand that 2 will get cancelled out. So h is proportional to what? To g. So you can relate this also with your formula. And by doing that, you know, the only force that is acting on the body at half of its maximum height is the gravity. And the gravity acceleration is equals to what? The gravity at that point. So that is the relationship. And from that, we can say the acceleration is minimal. We can say the velocity is maximum. The velocity is not zero, only at the top. The velocity is zero. The acceleration, its acceleration is constant. It's very correct. So guys, understand concept, understand how to solve question. It will really help you. Topic wise, tell a friend about our channel. Then we'll go to the last set of questions for this slide. Now, the number 9 question we have is that a rocket is fired upward. Rocket is fired upward. A rocket is fired upward. Let's just take an illustration. Rocket propulsion works on the principle of Isaac Newton's law of motion. We're still going to talk about all those topics. Don't worry about this. I promise you it's going to be a bomb. Like, it's going to be massive. Now, rocket is fired from the Earth's surface. There is the Earth. Gravity, we always act. We've talked about that. Such that it creates an acceleration of, let's just put a parameter. The body will be moving with acceleration that is constant. The acceleration is 19.6 meters per second square. If after time t, after t equals to 5 seconds, the engine is switched off. When the engine is switched off, that means, you know, it's going to come back. The maximum height, the height at which, at after 5 seconds, when the engine is switched off, the maximum height of the rocket from the Earth, that means the height at which the rocket will reach is going to reach when the engine has switched off, is what you need to understand. So let's just take this as a simple question using our equation of motion. Now remember, we know this formula very well, that S is equals to UT plus half AT squared. What is the second speed equation for linear motion? Now, the body is under gravity, remember that, and the body is fired from rest. So we can say the first height the body will undergo. Please get that. Now we say the body will move with an height of h equals to, you know that very well, half everybody know this, gt squared. I hope you know that, because if u is 0, a returns to g and stuff like that. Remember that v is also equals to u plus at. Let us get the velocity at which the body has reached at this particular time. So since body is starting from rest, the velocity the body will reach will be 0 plus the acceleration of the body was 19.6 multiplied by the time of the body is 5. So please, I would ask you to take g to be equals to 9.8 meters per second squared, because we are still going to need g, my dear students. So from here, we can say v equals to 0 plus 19.6 times 5. I think we can do that. We can use our calculator, which is going to be available on our computer. Let me bring out the calculator. But because of time, maybe I can just try and do that with my head, because there's no time. This should be 98. I'm not sure if I'm right. 19.6 times should be 98 meters per second. You can verify that. So if the velocity the body has attained at this time was 98 meters per second. So from that, we can get the height the body has also reached. Because the body has actually reached a particular distance at that point. So now we can, you know, the body has gone up and it is also coming down. What goes up must come down. We've talked about that before. So now, at that particular point in time, because when it's switched off, it's coming down. So we are having kind of two heights now. I can call the first height H0 and this one H1. So be careful about this type of question. But if you are used to my classes, I mean my classes on concept solving classes, this type of question, we've done a lot. Now, what you do here is just similarly, you now try to get your distance from the equation you call v squared equals to u squared plus 2ax. So you need to get the distance the body has traveled at this particular time. You can just always cancel u squared. So you can just say v squared, because 0 squared is always 0 squared, is equals to 2as. So from here, you can make a sort of formula as v is equals to 98 squared is equals to 2 times. You can see now, this is where something is, because you need to be careful not to make mistake. So we want to get the distance it has taken here. If we go by what we have here, our acceleration, I think we have acceleration. No, this is at our v square. I'm using 2gh. Please, I need the height it has attained. Please, so I'm using my g to be 9.8 times the h. On simplification, I'll get 98 squared divided by 2 times 9.8. So calculator wise, I don't know, this is so long. Sometimes UTME question are very, very funny. 98 squared is 98 times 98. I think that one should give us 96 over. Because if you are good in how to square number, this is 18.19.6. Please, you can always verify for error. Please, you divide the answer by 19.6. I think we are having 490 meters. So please confirm this. That is the height the body has reached at that point, at this velocity. So I have turned this one to gravity, which is 2dh. So this is 490 is the height this body has reached at this particular point. So similarly, the distance is covered at that point. Like I said, you can calculate from h equals to, because you have two heights now. That's the technicality in this question. You can see UTME is also very technical. This is 490 meters, so which is not the answer. So now we can now say similarly from h equals to half gt squared, half at squared. You can now say this is same thing as I'm using half times 10. No, this is not 10. 80 squared horizontal distance. That is what's that? 19.6 times 25. Guys, where is 25 coming from? Half 80 squared. Half 80 squared. This is 0. So I'm using this one to get the horizontal distance is also covered on the ground, on the earth. Half times is the same thing I've written here. Acceleration is 19.6 times the time square, t square, t square, t square. 5 times 5. For those of us that we need to understand the process. That is why I'm taking my time to explain. So simplification of this one will give you 19.6 multiplied by 25, which you can try that always. It's also good to know how to multiply. I think this is 490 divided by 2, which is very simple to divide by 2. Everybody knows that. And that is 245 meters. So that is the technicality. So the total distance on the, on the earth, because on landing, it will also move a distance. That is why we are doing this. So therefore, the total distance on landing will now be equals to the total H, or capital H. It is the one of gravity, which we have considered, 490, plus the horizontal distance, 245. And I think from addition here, this should be 735 meters. So that is the technicality. So guys, you can see the way it is. Sometimes some questions don't carry equal mark. So that is why you can have even numbers as your score in UTME. So guys, the answer to that is any technical question. It takes understanding to solve this type of question, but when you are used to them, they are very simple. The last question for today, my dear students, it's a ball is dropped from a high rise platform, well, at t equals to 0, starting from rest. Okay, parameter, time is 0, starting from rest. That's the first ball. After 6 seconds, another ball is thrown downward. Oh my word. So you can see UTME is not like before, because these are questions, these are the modern questions you see. It was what, interval of 6 seconds. The first one was the time of the first one was at t equals to 0, and the second one was what, after 6 seconds. Another ball was what, was also thrown downwards from the same platform. which is what? The platform that is high-rise platform or platform, to pronounce the word well. Now, excuse me, guys. Now, the question is, with the same what? With the same speed. They are using the same speed v. Initial velocity of the two balls is equal. Then we can say the two balls meet at time t equals to 18. Wow. So at time t equals to 18, the time they are meeting t equals to 18 is their meeting time. Meeting point, meeting time. So guys, what you just need to understand here is just to know the interval between the two balls. So if this time, if they are meeting at 18, that means what it means is what? The first ball might have moved at what? You know, the interval between them is, if this one is time t, this one is time t plus 6. Just a little bit of your algebra in mathematics. So time t and time t plus 6, time is not on my side. I am sorry. So what I'm trying to say now is that if they are meeting at 18, that means the first ball has moved for a time of what? It can be easily concluded that the first ball has moved for a time of 12 seconds for them to meet at 18, because the second ball at that time will be what? Will be at what? 12 plus 6, which is equals to 18. Do you understand that? So that is just the only thing. So at a particular time of 12, I get in it now. At the first bus moved for 12 seconds for them to meet at what? At 18 seconds. You understand that? Because the interval between the times are what? Is 6 seconds. So that is just the technicality in this question. So if you're able to understand and decipher that particular fact, it is very easy to get the answer. So now we are looking for the velocity. Let's calculate the distance at which that particular body has moved at that initial point. So if we say s equals to half what, or you say h equals to half gt square of half, because I'm using gt, half gt square for the first ball. So the distance the ball, or the height the ball has reached, because we are using h, please, you can turn s to h, times the g is 10, multiplied by the time this has reached, at that time is 12 square. On simplification, 2 here 1, 2 here 5. So we have 5 multiplied by 144. 12 squares are 144, if I'm not mistaken. So please always check times 5. That is 720 meters. I hope that is right. Okay. The two ball meet at 18 seconds. So the distance this has moved at that point. Let me get the time for 18 seconds. I'm going to get the value of what. Then for 18 seconds, I'll use the same thing. S equals to, we have, this should be equals to UT, that's half times 10. G is 10, is given times 18 squared. 2 here 1, 2 here 5. So we can say 5 times 18 squared. 18 squared is that is 324. So 324 times 5. I'm trying to do that with my brain. Should be 100, and that is 16. That's 1,620 meters. So at this point, the two balls are actually meeting. So keep that at the back of your mind. At this particular point, at 18, two of them are meeting. But at that particular point, we want to know the value of the what? Of the speed. So that is what we are to calculate. And to do that, my dear students, it is very simple. All what you just need to do is just to set relationship. You need to set relationship, because without relationship, you cannot get this. So now what I've done is, at 18 seconds, this is the distance. So at that particular point, the distance moved by this is equal to the distance moved by this. So at this, ball was dropped from a height of what? From a particular height after 6 seconds. After 6 seconds. The initial time is 6 seconds. So note that after 6 seconds, the ball, so if this one has moved after the interval between the two balls is 6 seconds. So now how did I come about 18? This is where they move. So what I want to do now is I want to send a kind of relationship. If this one has moved a distance of 12 seconds, this will have moved what? The meeting point is what? That means the first one has moved for 12 seconds before this one, because the interval between them is what? t and t plus c. So back of your mind. So the distance moved in 18 seconds is 1620. So we can say the distance moved by the first ball in 18 seconds is the distance moved by this in 12 seconds. That's the relationship I will set. So going by my full formula, which is S equals to ut plus half at squared. So we have this should give us the distance moved by the first ball in 18 seconds is 1620. Just have to be careful sometimes. 1620, that's 1620, is now equals to u, which is the value of the speed we are looking for. Distance moved by the second ball in 12 is now plus my half at squared. I think I've done that, had 720. So what I did here, guys, is that the distance that has been covered by the first ball in 18 seconds, which is their meeting point, is the distance that will have been moved by the second ball in 12 seconds. Because that is 6 seconds ahead of the first one. So please, understanding question goes a long way. I've done a lot of questions on this. So now directly we can just solve this to get the value of u. On simplification, I think this should be 1620 minus 720. So that is like 162 minus 72. If I'm not mistaken, 162 minus 72 should give us 900. So I think this is 900. I am collecting light times my dice length. 900 is equals to 12u. So here we say u equals to 900 divided by 12. So that's 900 divided by 12 will be 12 times 6 is 84. 12 times 6 is 84. And that should be, I think, there's a mistake in what we saw, or there's a mistake in question. No, 12 times 7, that is 75. 900 divided by this should be 75 meters per second. So guys, this is the answer to that, and that is option A. So guys, you just need to be careful about some questions. As you can see, you just need to understand the technicalities and the new pattern in which UTME are setting questions nowadays. So guys, this is where we stop for this on motion in one dimension, which is mostly your linear motion and what's the topic of motion. So the next day, which is tomorrow by the grace of God, we go to another topic. We are taking them topic by topic, 10 questions daily. So if you find this video interesting, don't forget to subscribe, like, and share the content with your friends which you think are also writing the examination. So guys, see you soon in my future video. Thank you and remain blessed.